Okay, I'm very happy to be here. I'm talking about building individual data products for social good with Python, PostgreSQL, and Vue.js. So this will be the agenda. So I will start talking a little bit about the motivation. So basically where this is all coming from, and then afterwards we dive into what could be alternatives and why not simply use other tools for this. Then I'll introduce some examples from the real world, describe the current stack. We use this stack at Correlate and also using this stack at cause&effect. And then I talk about some alternatives for this stack. And then I provide you with some links and some recommendations, how to get started. And afterwards we can, discuss. And you have time to ask questions. So my name is Jan, as you already learned. I'm a co-founder at cause&effect. Originally, I studied politics in Constance and then switched to data science and global studies in Constance and Gothenburg, and worked as a working student as PwC as a data scientist. Yeah, that's basically it. You can find me on Twitter, and if you want to write me an email, you find my email address here. I guess the slides that will be shared later on. So what's basically the motivation behind having a stack for data science and to build individual data products? So one of my first experience with web development was the LAMP stack, probably very well known. So LAMP stands for Linux, Apache, MySQL, and PHP. So Linux is the environment, MySQL is the database, PHP, the programming language, Apache is used as the web service, and you can see how these tools are usually linked. So PHP is writing and requesting data from MySQL. This is given to Apache, and Apache is responding to a request by the browser. This has developed during the time to a more or a stack which is driven by JavaScript, namely Node.js. And there you'll find MongoDB, a NoSQL database, Express.js as a server, and usually a proxy such as Nginx or Apache, which is used to forward the requests to the Express.js app. And then in the browser, you will find Angular, React, and Vue. And the difference between the mean stack and the LAMP stack is basically that you find server-side rendering in the LAMP stack and browser-side or client-side rendering in the mean stack. And here you see the difference. There's mean, MERN, and probably Maven. And these is namely for Angular, React, and Vue, the different frameworks for the front end. So what do we need to set up our individual stack, and why do we need a different stack than So we need a setup that is flexible enough to run out of the box, which allows to be customized when needed, is modular enough to be reusable, and all these 3 points can be applied at least to the mean stack. However, these stacks do not allow to integrate data science technologies, because most of our data science technologies are based on Python, and therefore we need something that integrates with Python. So from there, we have a different kind of stack, which is based on Python. Here we use Fast API. Later on, I will introduce some alternatives to Fast API. We use PostgreSQL as a database, again, a proxy like Nginx or Apache. and in the front end we use Vue. And to make this a little bit more flexible, it could also look like this, that instead of using Postgre, we also could use Solr as a database, or we could use both, or we could use SQL Server by Microsoft, or we could use Oracle Server, whatever. And we can make it even more complicated and use different client technologies. So we could serve it to the browser, which can run Vue, Angular, or React, or we could also provide data to an R package. I don't know, should we have the questions in between, or should we continue?
I don't know whether there are any questions.
Are there any questions? Yeah, that's
no, there are no questions already. So please just continue. Yeah.
Okay, now let's continue, I would say.
But if we are totally losing some people with like the technical things, please shout out in the chat and yeah.
So the next question is, why not simply use, and then we will have some different tools. For example, why not simply use BI tools? Ilya in his talk already talked about Metabase. Other commonly known tools are Power BI or Tableau or ClickView. And basically, when we go back to the criteria we had, BI tools only check one of the boxes. So BI tools are flexible enough to run out of the box, but they don't integrate nicely with common data science technologies. We can't really customize them, and they're also not modular enough to be reusable for us. Next is Shiny, which is based on R. And I would say Shiny ticks two of the boxes. However, that can be discussed. I think Shiny is a great tool if you're prototyping something. I have to say there's a short or a little disclaimer. I didn't properly touch Shiny code for like 2 years, and I think there has been a lot of development, especially if you look at packages like Golem. And I think a lot of the stuff improved. And I think Shiny has been used a lot at Correlate. So I think there was the Alasia project by Dennis and Antonia, which was already presented today, I think. And then at the Correlate X chapter, local chapter challenge, I think some of the teams also used Shiny. However, for me, the last 5% to achieve a nice design and to make everything as you wanted felt always like fighting against the framework, and has always been a little bit more like hacking than really programming. And that was always really hard. So my feeling is that if you really want to customize your system, Shiny is probably not the way to go. Therefore, Shiny allows not to be customized when needed. And I also think Shiny is not modular enough to be reusable across projects. Next up is Dash. Dash is a little bit more customizable than back. It uses React, and you can simply manipulate React components. However, it's bound to Plotly.js, but however, Dash is not modular enough to be reusable again. So concluding, neither BI tools, Shiny nor Dash, provide a real separation of concerns. So we mix up backend and front-end code, cannot swap single components when needed. And that brings me to the examples from the real world. I shortly have to grab my power cord because the power cord I'm using, wait. That won't work. Okay, sorry. Can you still see my screen? Okay. So the first example I brought is level 2 visualizations. So this was a Correlate project last summer. It was a hackathon together with GLIVE. GLIVE is the Global Legal Entity Identifier Foundation, which was founded in June 2014 by the Financial Stability Board. And the idea behind GLIVE is that they provide an LEI, which is a unique identifier for companies. And this LEI should support the transparency of markets so that you can identify who belongs to whom. And therefore, they provide two data sets. The first is the level 1 data, which basically is who. So it includes the company name, it includes the LEI, it includes the legal address, and so on and so forth. And level 2 data shows you which company is related to which company. And as you can see on the screenshot, we developed this nice tool where you can visualize these level 2 data, and you can simply draw a graph from the relations between the companies. And this one, for example, is for Samsung Electronics, which is based in Germany. You can see it in the light blue, and it's related to the main Samsung company on the far left. So the technologies we use here are Docker, Fast API for the backend, Vue.js for the front end, and for the visualizations we use Vue.js. On the slides, you can find links to the blog entry or the blog post where we describe the hackathon itself, also to the tool, so you can use it and you can search for entities. However, the data used there is quite old because it was a prototype, so we only linked a static file. We don't have any database technologies in here. And you can also find the code online because it's open sourced. It's on GitHub, so I linked the client library here, but you can also find the backend library, which is linked in the README. Next up is the digital report 2020, which was a project together with Haus des Stiftens, the University of Mannheim, which was funded by the Ministry of Interior. And it was a survey on the state of the digitalization in NGOs. And it includes responses from 5,400 NGOs across Germany. And we visualized the results, and we also included a self-assessment to measure your own digital maturity. So the technologies we used were R and Vue.js. So we visualized and processed the front end in Vue.js using Vuetify, and all the data wrangling happened in R beforehand. So if you want to visit the digital report, you find the link below. And finally, the Mandatsrechner project, which is also a Correlate project, basically a Correlate X Berlin project. And recently there was an update of the electoral law in Germany. The laws discussed, and the idea behind the tool is that we showed differences between the different laws. And the idea is that we provide information and details to the public and politicians with simulations of the distribution of seats among the parties. The technologies involved here were PHP, so we used PHP in the backend to do the simulations. And then in the front end, we used Vue.js and Chart.js. Vue.js again as a front-end library, as the framework, and Chart.js to visualize everything. You can also find this tool online when you visit the link below. Any questions so far to this point? Oh, Thanks for copying the
that's fine.
links.
No, I don't think so. But yeah, Ilya just commented that he also, I think he agreed with you on the Shiny stuff and also on the AI, not on the AI, on the Tableau things. He also
on Tableau, yeah, I can see it.
Yeah,
nice.
He said that it's also expensive and you don't own it. That's also a reason to not use those kind of tools. Yeah. Okay, but
totally agree. Yeah. So let's come to the current stack. So we are using mostly PostgresQL. In our opinion, the pros are that you can easily work with geographical data with Postgres. So that's add-on to install with Postgre. And they support nicely full text search using tsvector and tsquery, which is quite easy to implement. The contra is that most organizations we work with tend to use MySQL, MariaDB, or SQL Server. Yeah, for whatever reason, because you have to pay license fees for SQL Server or Azure SQL. And Postgre and also MariaDB are open source and you can freely use them. For backend framework, we use Fast API. Pros, in my opinion, are parsing and validation is working with Pydantic, which is really nice. It supports the SQL Alchemy ORM, which connects different databases, and support for multiple databases is quite good. So you can simply switch your connection string, and you can switch between a Microsoft SQL server and Postgres by just simply switching the connection string and working with the same code without adjusting any or touching any SQL code. It automatically generates OpenAPI documentation for you. The documentation of the tool itself is really, really solid. So you find loads of tutorials just within the documentation, and they basically lead you through all important problems and introduce all the features that are available in Fast API. I think it's probably one of the best documentations I've ever seen. And there's a really nice starter template using Docker, Postgre, and Vue.js. However, we never used it, but it's very nice to start. One contra is that it's a really young framework. So even though you find some issues on Stack Overflow, it's not comparable to Django or Flask. However, the community is very vivid, and I think there is a Discord server, if I'm not mistaken, which you can easily join and you can ask your questions. And I think there are like hundreds of people in there which happily answer your questions. This is a short example how Fast API code looks actually. So with these 15 lines, you already implement a server providing you fruits and listing you fruits. And the nice thing is that it automatically parses query strings for you and also URL parameters. So in line 8, you see the declaration of a URL parameter limit, basically in brackets. And if you add it to the function below in line 9, this is automatically read from the URL. And you also can easily add query parameters by adding parameters to the function in line 9. Here you can see T for transformation, and it's defined as an optional string, so you don't have to set it. And you can also define that it's a query parameter which has to match lower or upper using regex. So you can basically define which can provide. In the front end, we use Vue.js. The pros is definitely the Vue CLI, which provides you with a complete project setup. So you don't have to think about where to put which files. everything will be set up for you, and it will also provide you with example code just in setting up the app. An additional feature are Vue Router and Vue Vuex, which are also provided in similar frameworks like React and Angular. However, Vue Router and Vuex are supported or developed by the Vue core team, so they are really entangled with the Vue core. It's sad that Vue has a really flat learning curve compared to other frameworks. However, I started to learn Angular, which is definitely not comparable and really hard to learn, in my opinion. And yeah, React is probably similar, a little bit harder. And another pro is definitely Vuetify. Vuetify is a framework to provide you with material design components. So basically it provides you already with a setup how the app could look like in a Google design way. So material design is a Google design schema. I also brought an example. So this is a Vuetify table. And on the right, you find the code to set that up. That's basically the code to set all this up. And that's really not a lot for front-end code. For those who program front-end probably know that. And one thing I wanted to show, which is really nice in Vuetify, if you look in line 3 in the lower code example, unfortunately, I missed the coding lines here, the editor lines, the numbering. You can simply switch the key dark from false to true, and you will have a dark theme and a light theme without changing anything. This will be applied automatically for you, and this is really nice. Finally, visualizations. Currently, we are using high charts. However, we are thinking about switching. Coming to that in a second. So the pros of high charts are definitely the flat learning curve compared to D3. So high charts is based on D3, but is simply a high-level wrapper around D3. You have a library to bind high charts natively to Vue.js so that it's reactive, which is also very useful. So when you fit in new data, you will have nice animations. And the whole framing is very mature, and there's an active support. But this is also the downside of the library, because it has a really weird pricing scheme. So when you use it, you have to buy a developer license for your clients, but these kind of license or the description of the license changes, I don't know, every half a year or something. So we already had 3 different licenses for 3 different clients, which is a little bit annoying. Here's a short example for Parliament visualization. And on the right, you find the setup of the chart, which includes basically just options. You just say, you just provide the data, and you tell how the chart should look like, and you define what type of chart it should be. And then the rest is automatically set using D3. Any questions? Okay, then I will continue with the alternatives. So basically for all the parts for the database, the backend, the front end, and also the visualizations, I brought some alternatives because in my opinion, you should really look in the elements of your application and then choose the tools you use based on this, and not probably fit the tools to the problem, but the other way around. So databases is a little bit boring. You have the SQL side, or the relational databases, SQL Server, MariaDB, MySQL, Oracle, and all that stuff. They're not that different. However, some are not open source, some are open source. For some you need a license, for some you don't. And we have the NoSQL side like MongoDB, Solr. And then of course, with what is missing here is GraphQL. But since I've never worked with them, I left it out of here. Then we have the backend side, and there I would differentiate between Python and R. Since we are usually working with data science tools, and most of the data science stuff we work with is implemented in Python or R, I think those are the most important frameworks. So Django, Flask, and FastAPI. I also added the first commit date of the GitHub repositories. It's really interesting, I think. Django was already 15 years old, Flask 10 years, and FastAPI just 2 years. And this correlates with the number of issues on Stack Overflow and also the environment. So you find a lot of plugins and add-ons for Django, a little bit less Flask, and nearly none for FastAPI. However, this is rapidly changing. In R, you find Plumber, which is not that mature in my opinion. I'm used to work with that too. However, it's really nice if you want to deploy a R model, and you easily can set up a server using Plumber. There are also other frameworks, as I said, in PHP, for example, Laravel, or in JavaScript Express and Feathers, or in Rust Rocket. But those programming languages, in my opinion, don't provide that nice data science tools as we have in Python.
Jan, you're running a bit out of time.
Yes. Oh, that's bad. Then I would
skip. If that's here, okay, I mean.
And provide the slide?
Yeah.
Yeah, okay. Probably let me come to my summary, and this only one slide, and then totally. I'm finished. Okay, so basically what I want to say with all the alternatives is I think front-end visualization and also databases are interchangeable, but you should choose your backend framework really wisely. And in my opinion, it should support 3 points. One is an ORM that is compatible with common database systems so that you can simply switch between databases. One that allows you to easily use your go-to data science tools, and which provides you a proper documentation out of the box, because that's usually a pain in the ass. And if you got the slides, you will find some tips and links to start yourself. Okay, thank you. Are there any? Nina says your stress resilience is on fleek. It's very good. Okay, any questions for Jan? I also just wrote in the chat, did I? Yeah, that I extended the session duration. So even in the coffee break, it will still be here. It just won't disappear. So we can maybe also discuss a bit in the coffee break if you're fine with that. Yeah, then maybe I will give the stage to Gesa. Thank you, Jan, for the very interesting talk. Yeah, thanks for having me.